This video is going to cover grid calibration for a fixed camera. So the first thing we need to do is open up our Internet Explorer and make sure that we set our compatibility and set our trusted sites so that we can access the server. So remember, you need to make sure that you uncheck the require server verification HTTPS, which means the S is for security, or which means encrypted. We need to make sure that we add our IP address in here for our robot, and then we can go to the robot's home page, which I'm at, and I'm going to run Vision Setup. And you can see here I already have a fixed camera, so we're just using the standard Sony analog camera. And so now I'm going to go to Calibration Tools, and I'm going to create a new calibration. Okay, and so we have two options here, either grid pattern calibration or the robot generated calibration. In this case, we're just going to do the manual grid pattern. And so I'm going to give this a name. I'll just call it Heart Cow. So this is fixed camera calibration for user frame 6. Okay, so I've already topped my user frame. Using the 4-point method, I have topped my user frame to match the grid. And so now I'm going to open this up. And the first thing you have to do when you open it up then is to select your camera. And then you will probably have to set your exposure time so that you can clearly see the grid. I'm also going to zoom in on this so that I can see the grid fairly well. And we can try changing our exposure. You may also need to maybe adjust your focus a little bit on your camera. I'm just trying some different values here to see how well we can see this grid. All right, so what we've done is we've selected our camera, and we set our exposure time so that we can see the grid. And we need to also make sure that we set the grid spacing. So this is the dots on this grid are actually separated by 30 millimeters apart. Okay. And still trying to find a exposure time that I like here. Okay, I'm going to start out, I'm going to try 9. We may have to adjust it. All right, so you can do the calibration on just one plane or two planes. In this case, we're just going to do one plane. And the robot does not have the grid. The grid is fastened. The camera is fixed to a frame. It's not moving, and the grid is also fixed to the frame. So neither one of them are moving in this video. And we're going to use user frame 6. And we want to use an orthogonal, since we're only using one plane. We really need to use an orthogonal because we just need to make sure that we're like perpendicular. If we were using a couple of planes, then we would choose the perspective option. And so now what we're going to do is we're just going to set our grid pattern. So we're just going to click on set here. and then we're going to find our plane. So when we find the plane, we get this box. And what we want to do is you want to highlight just the grid. So as you can see, our camera sees a lot beyond the actual grid. So we want to take this box and get it so that we mark the grid. Now, depending on your camera field of view, sometimes you may not see the whole grid. Sometimes you may only see part of the grid. That's okay as long as you can see the 4 main dots. Okay, so if you didn't have the whole grid in your field of view of your camera, then you don't have it. That's okay. But you do have to have the 4 large dots. Those are critical. So now, once I've did a find, you can see that it finds all of those dots that I selected within my pattern. But if we zoom in on these a little bit, let me zoom in even more, you see that some of them show some red. Okay, so the red ones are kind of showing like off center. Or so you see like the red there, like number 14 right here has an awful lot of red. It's got like a full red cross. So does like number 12 over here. Okay, where if you look at number 7 doesn't show quite as much red. And or number 60 down here doesn't show quite as much red. All right, so but you can see the 4 large dots are 1, 2, 3, 4, right? Those mark the x-axis. In this case, the x-axis is going straight up or almost straight up, and then the y-axis is going to the left. All right, and so again, we have to have these 4 main large dots in the field of view of the camera. All right, but these red marks here, the ones that are kind of marking out are red, it's basically saying, not quite sure about those dots. So I got a lot of dots that look great. They're just perfectly green. They're not showing any kind of red, but we got some that are showing red, and it's, some of them are even interspersed around there or whatever. But what we need to do one thing we can do is we can just come over here and look at the data tab. All right, and the data tab shows the position of the camera relative to the calibration grid. All right, so it shows the X and the Y values and the roll value. And then it shows the position of the grid to the frame. And of course, the robot is not actually holding the camera, so those values are empty. But now if we come over to points, okay, so here you can see the points, and notice I'm not quite sure how they decide the order of these points. Obviously 1, 2, 3, 4 are the 4 main dots. But then here's point 5 up here at the top, and then 6 is over here, and 7 and 8, and then we got a 38. So I'm not quite sure how they come up with these numbers, but the key thing that we need to really know here is this error. So if you look at this last column, it's labeled error, and if you click on that, it'll sort by the error, and you can see it's got the errors are really small. 0.002, but if you click on it a second time, it'll sort in reverse order. And you see here, like number 6, it's showing a lot of error on number 6, okay? And number 9 is showing a lot of error. Well, number 9's kind of cut off anyhow. So what we want to do is basically, if your error is greater than 0.5, then you want to probably get rid of it. So what we're going to do is I'm going to take this number 6 and I'm going to delete that. And then it's going to recalculate ignoring that grid point. So you see that grid point that was 6 is now just, there's no green in there. There's no number assigned to it because we dropped it. So it recalculated. So the one to the right now is actually called 6. All right. So the numbers change every time you drop a point. All right. And so again, we got like number 25 now, and you can see it highlights them as we go through. But number 29 is the one with the most. 25, number 25 is the one with the most error now. So I'm going to delete that one also. All right. And if you look at this, like you see, like number 16 is now the one with the most error. And the one right below that is 603. But when I delete 16, okay, then you notice the next one with the most error, the error actually went up now, because even though, because the next highest error was 603 because we had just dropped the 605. But what happens is, even though these points that we have already dropped had quite a bit of error, by including them, we're getting we're getting some spacing information from them. And so you don't really want to delete too many in here, but it's helpful to get rid of the ones with the largest errors. So you can delete a few of these, and the ones with the biggest error, go ahead and delete those. But now if you look, my error on this next one, it actually went up way more than what I had. Okay, so when your error starts going back up on your points, I think at that point you're pretty much throwing away more information than is really useful. So if you need to, you can come back and redo your find. Okay, you can also maybe try to recalibrate your or not recalibrate, but change your exposure time. Okay, and try it again and see, so till you get something that you're happy with. All right. But I do want to point out though that this grid here, again, like I've got number 9 right up here. Of course, that one has a high error of 0.662, so I'm going to delete that one. And the next error here was number 6. Okay, which again, it's the same one it was a little upset with before, but that's an error of 631, so I'm going to delete that. Okay, and 15 here, I guess I'll delete that one. Okay, and then my error popped up again, so I think I'm just going to stick with this. But this is actually this is not bad. This grid looks pretty nice. You're getting a good show on this grid. You can see the points pretty well. It seems to understand where the grid points are at pretty well. So these values are actually very good. So it's a good view of the grid, and so it should be a very good calibration. So I'm going to go ahead and click and save that and end that. And so now this is my calibration. So when we go to process tools, okay, and remember, like when we looked at process tools, we had like the inspection. The inspection didn't need a calibration. However, pretty much all the rest of these do require your calibration to be set. So you need to make sure that you have your calibration, which of course I do. I have this calibration here, and we can come back into it and edit it or touch it up or something as we need to. All right, but this is a pretty decent looking calibration. I think it'll work pretty well so that we can go in and actually create a single view or a multi-view process and then have the robot be able to determine where the part is and apply the appropriate offsets to like pick up and move parts when it sees them with the camera. All right, so just as a review here again, when we first came in here, we had to select our camera and select our user frame. Actually, I apologize. I meant to use user frame 6. So I'm going to have to redo this again. I forgot to set this. My application frame is user frame 6. And the calibration grid is also user frame 6 for my use here. So I'm going to have to reset this, but we set exposure. You need to make sure that the grid spacing matches your particular grid. The grid actually says on it what, on the one side of the grid, it'll tell you what the spacing is. Okay, and set the number of planes, whether the robot is actually holding the grid. And so I'm going to set this, and I'm going to do my find again. Okay, and then I'm going now. What I wanted to show you here, the position of the calibration grid relative to the application frame, because I set them both to 6. Okay, so I set both my user frame this time and the calibration grid frame to 6. You can see here that the position now it is 0, right? Because the as I mentioned before, I've already taught frame 6, user frame 6, to match my grid. And so therefore the offsets here are 0, which I just find that this makes it the simplest for setting up vision processes and setting up your offsets. Okay, so if you go back in the video and watch the first part where I didn't change the user frame defaulted to the world frame, frame 0. And so these values right here were based on that frame, and these values then were not 0. All right, but so then we can come in, we can look at our data points. Okay, and again, I've got like data point 9 here, so I'm going to delete that one. Okay, and data point 25 is the next highest this time. Okay, I'll delete that one. And I think that I'm just going to stop there. Oh, that looks really good, actually. You see I've got my errors are at least all below 0.6. Okay, so it's a little bit better than what I had before. So I'm just going to save this. Okay, and that will be my calibration that I can use for identifying parts.